Levi-civita symbol. The three-dimensional Levi-civita symbol is notated by epsilon ijk. It is defined as epsilon 1, 2, 3 is equal to epsilon 2, 3, 1, that is equal to epsilon 3, 1, 2, that is equal to 1. 1, 2, 3 in the cyclic form. Okay. If in the form, if epsilon 1, 2, 3, its value is 1, 2, 3, 1, its value is 1, 3, 2, 3, 1, 2, its value is 1. If any one of this pair interchange, that is 1, 3, 2. Okay, 1 is the 2 and 3 interchange, 3, 2, or epsilon 3, 1, 2, or epsilon 3, 2, 1, its value is -1. Okay, that means it is anti-symmetric with respect to all pairs of indices. When we change two indices or a pair of indices, its value become -1 or -1. For all other values, epsilon ijk is equal to 0. That is epsilon 1, 1, 2 or 1, 2, 2, or if any one of these indices repeated, its value is 0. So this is a Levi-civita symbol. In general, we can write epsilon ijk is equal to 1 if ijk are even permutation, or its value is -1 if ijk are odd permutation. For all other values means if the index, any one of the index repeated, its value is 0. This epsilon ijk is a third order tensor and it is also a pseudo tensor. It is an isotropic pseudo tensor. A tensor which have same component in all rotated coordinate system. We call that type of a tensor as an isotropic tensor. A tensor whose components remains unchanged after rotation. So that type of tensors are known as isotropic tensors. So epsilon ijk, its values will not change after rotation. Okay, so it is known as isotropic. Scalar is an isotropic quantity because its value unchanged after rotation. Its value is 2 after rotation also. Similarly, this Kronecker delta is also an isotropic tensor. So let us discuss some problems of this. Okay, first problem is show that delta II is equal to 3. We know that delta II is a Kronecker delta. Kronecker delta is a mixed tensor, second rank tensor. We already discussed it. So II means according to Einstein's summation convention, the repeated index should be summed over in 3 dimensions. Normally we are dealing with 3D space, so it should be summed over. I means the component is repeating, that means according to Einstein's summation convention, it should be summed over the all values of I from 1 to 3. So it is I is equal to 1 to 3 delta I. Actually we can write delta as 1, 1, 2, 2 and 3, 3. We know that Kronecker delta, when it is 1, 1, its value is 1. If it is 2, 2, its value is 1. If it is 3, 3, its value is 1. So when we sum over this, you will get its value as 3. So we prove delta II is equal to 3. Second question. Show that delta Ik, delta epsilon IKM is equal to 0. Delta Ik, Kronecker delta Ik and epsilon. That is Levi-civita symbol epsilon IKM is equal to 0. So delta ik epsilon ikm. There are two conditions when I is equal to k. When I is equal to delta ik can be written in this manner because it is a mixed tensor. Ik epsilon ik. So if I is equal to k, delta ik is equal to 1 because this when I is equal to 1, its value become 1. It will this chronicle delta will exist only if these two indices are equal. So when I is equal to 1, it will increase. But when I is equal to 1, I is equal to k, this epsilon ikm become epsilon iim. So in the case of a Levi-Civita symbol, if an index is repeated, its value will become 0. So its value is 0. So if I is equal to k, this will not exist, its value will become 0. So let us check what happens if I is not equal to k. If I is not equal to k, even though this Levi-Civita symbol have a value 1, but this chronicle delta when I is not equal to 0, its value is 0. Then also delta ik epsilon ikm is equal to 0. So that's the next one is dual tensor. With any anti-symmetric second rank tensor C, we can associate a dual pseudo vector, that is Ci. Ci, we know that is only one in indices, that means it is a vector. Normally it is called pseudo vector because it is equal to half epsilon ijk cjk. Epsilon ijk is a pseudo tensor of rank 3. So here Cij should be antisymmetric, then only this condition will exist. So if Cij is antisymmetric, what is antisymmetric? Antisymmetric means for a tensor to be antisymmetric, its diagonal component should be equal to 0. And this there is a uh, if this component is C12, this should be minus C12. If this is minus C31, it is C31. If it is C23, it should be minus C23. This type of tensor is called anti-symmetric tensor. Okay, there is a symmetry, anti-symmetry between about the diagonal axis. If it is positive quantity, it is negative. If it is negative, it is positive. If it is positive, it is negative. Okay. Here Ci is a pseudo vector. It transforms as vector under rotation. You know that the difference arises only because of inversion or reflection. In the case of rotation, it remains same as it's transformed as a vector under rotation. So it is formed from this double contraction of a fifth rank pseudo tensor. Epsilon ijk is a third rank tensor. Cm, it is an antisymmetric tensor of second rank. So total multiple of epsilon ijk and Cmn will produce a fifth rank tensor, and due to its contraction, if two indices are equal, it will reduces into a first rank tensor, that is Ci. The component of Ci is given by, so the C1, C2, C3 is given by C23, C31, C13. After contraction, its values become C1, C2, C3, that is given by C21, C23, C31 and C12. For C12, there is a one-to-one correspondence C1, okay, that is equal to C23. After 1, 2, 3 is the even permutation, so it is C1, here C23. This is C2, here 2, 3, 1, C3, 1. Here C3, it is 3, it is 1, 2. So cyclic order of indices come from the cyclic order of the component of epsilon I, j, k. So this Ci is a pseudo vector. Okay. And the duality, that is, we know that C1, C2, C3 is equal to C2, 3, C3, 1, C1, 3. Means that in 3D vector product may be literally taken to be either a pseudo vector or an anti-symmetric second rank tensor, or any anti-symmetric tensor can be associated with a dual pseudo vector. Any anti-symmetric tensor can be associated with a dual pseudo vector. So this Ci is associated with a pseudo vector and also with an anti-symmetric second rank tensor. So that is known as dual tensor, and it is pseudo. So we call this as a dual pseudo vector because it have only 3 components because of this contraction. So this type of tensors is known as dual pseudo tensor. In simple case, we can call that dual pseudo vector. Irreducible tensor. Any general second rank tensor Aij is reducible. We can reduce the rank of a tensor by contraction, which means that it can be decomposed into parts of lower tensors. For example, Aij is a second rank tensor. We can write A as Aii. So Ai, by creating two coordinate equal, it becomes a scalar quantity. Vector becomes a scalar quantity. So, or this A, Aii, what is Aii? I should be repeated. So it's A is nothing but A11, A22, A33. Actually, what is A11, A22, A33? In the case of a tensor Aij, it is nothing but trace of that tensor A11 plus A22, A33 is the trace of tensor Aij. So we know that if Amn is equal to Anm, then that type of tensor can be this is a symmetric tensor. It may be, it is represented as a contravariant tensor. We can represent it both as covariant. In the case of covariant tensors also, Amn, if it is in the subscript, it is also equal to Anm in the subscript. In the case of a second rank symmetric tensor. Or we can write if Amn is equal to minus Anm, it is anti-symmetric tensor. If Amn is equal to minus Anm, it is an anti-symmetric tensor. Or we can write any tensor Amn can be written as half Amn plus Anm plus half Amn minus half Anm. Okay, this bracket is not common. If half is taken outside, this bracket will be common. So that means we can resolve any function or a tensor into a symmetric part and an anti-symmetric part. This is symmetric part of the tensor and this is the anti-symmetric part of the tensor. Here half Mn plus half of Mn plus Nm is symmetric and half of Mn minus Anm is anti-symmetric. So the anti-symmetric part of Aij is nothing but half Aij minus Aj. So this is anti-symmetric part. This can be replaced by Bij. So Bij is nothing but the anti-symmetric part of Aij, or Bij can be written as half into Aij minus Aji. So we already studied that for any anti-symmetric second rank tensor, there associate a dual pseudo vector. So the dual pseudo vector associated with this uh, anti-symmetric second rank tensor is Ck, or we can write Bij is equal to Ck. Ck, okay. So this is also the cyclic permutation Ijk, arises from the cyclic permutation of Ijk. So by subtracting a scalar A, what is scalar A? That is trace of A, and a vector, that is and a Ck, that is anti-symmetric part of that tensor from the original tensor. So from the original tensor, when we subtract its when we subtract its trace, what it will become traceless, a vector or a tensor, and after subtracting its anti-symmetric part, it will remain symmetric tensor. So from original tensor, we have an irreducible, symmetric, zero trace second rank tensor Sij, or Sij can be written as Aij, our original tensor, minus half Aij minus Aji. It is the anti-symmetric part of that tensor, and minus 1 by 3 A delta Ij. This is the trace portion of that tensor. So when we multiply these two quantities from Aij, we will get an irreducible, traceless, symmetric second rank tensor. It is known as the reducible form of that irreducible form of the tensor Aij. So Sij is the irreducible form of tensor Aij, and Sij is given by half bracketil Aij plus Aji minus 1 by 3 A delta Ij. Thank you.